Yes, sir.
Okay, good morning. I would like to thank the organizers, CII, for inviting me as a chair for the session on digitization and industry 4.0 and key technologies for net zero. Over the past 4 decades, I have been a part of cement industry and I have seen close how the manufacturing process evolved over time. While traditionally cement manufacturing has been considered as a polluting industry, but I believe rapidly it is changing with the help of technology and breakthrough in alternative fuels and usage of green energy like solar, wind, and waste heat recovery system to reduce the need of the coal and other fossil fuels. Further, to reduce the pollution and drive us to net zero. In addition to this, Industry 4.0 technologies like artificial intelligence, IoT, blockchain, and robotics have already started improving efficiency and safety in many parts of the plant operations and supply chain. I cannot be more excited about the future of the industry, but I'm sure many of you here will have a case studies and learnings to share on how we can go close to the net zero by 2070 and various digitization and industry technologies. And if you see the 4.0, normally when it end of the 18th century, when the industrial revolution has started, the people were using only mechanical production machines and powered by water and steam. And in 20th century, it has started beginning some rail movement, some engines and everything. Third, in 1970s, ITS, electronics and ITS further progression in autonomous production. And today, industrial revolution on cyber and physical systems, IT systems, everything it has started. So like this, now even with the AI, people have started using AI in various applications, in especially in cement industry. And moreover, we have recently installed fuzzy logic in our PXP in our kiln operation system. It is running auto mode. So automatically it reduces the feed versus coal. Automatically it reduces the coal consumption. By with this we can reduce the pollution and CO2 emission. So I think our speakers, Mr. Tejas Gowda, he is from I think ABB. He will talk about plant reliability. Am I correct, Mr. Teja?
Yes, sir, exactly.
Yes.
Am I audible, sir? Yeah.
Yes. And Mr. Roshni is also there from Industry 4.0 expert and knowledge lands. And other two speakers are yet to come. And once again, I'd like to thank CA for this. And we can start the session. In between, we will have some question and answer, or otherwise, at the end of this session, we will have question and answers. Okay, thank you. Thank you once again.
Yeah, thank you very much, sir. Thank you very much, sir.
Yes.
So now we would like to invite Mr. Tejas Gowda from ABB. Sir, you can share your presentation. You can start.
Yeah. Thank you, Sairami sir, for your introduction.
Yes.
First of all, I am Tejas. I'm working as a smart solution manager in ABB. So I have 3+ experience in the current role which I'm working. So first of all, I would like to thank CIA for bringing all the industry's expert in this virtual forum and giving ABB an opportunity to present in this 2 days of event. So I'll quickly share my screen. So can you confirm whether the screen is visible or not?
Yes, it is visible. Just make it full screen, sir.
Yeah, thank you. So today, as Sai Mr. has already mentioned, so I'll be talking about this digitalization and industry 4.0. So these are the key technologies for net zero. So here, basically, what I'll be talking about is that how this digitalizations, which will boost the plant reliability and the efficiency, and thereby reducing the energy consumption. So this is the topic that I'll be covering. So first, this is the overview of the session. So these are the topics that I'll be covering in this 20 minutes of the session. So first, we'll talk about the introduction, why this energy consumption is predominant in this current scenario, and what are the main causes because of which the energy is getting wasted in the electrical system. So what are the ways in which we can reduce, and what as ABB we are offering to the customer? So that we will discuss. So this energy, ABB energy appraisal, ABB ability condition monitoring, and ABB ability condition based maintenance. So these are the solutions which will improve the energy efficiency of your system and the reliability. So we'll talk about in detail of these topics, and then then we will summarize all the things that we have covered in this session. So first, talking about the energy. So as you all are aware, the global population is expected to rise by 9.7 billion by 2050, and economy will be doubled by 2050. So this urbanization and the rise of living standard will also increase. So this will increase the demand of energy in the near future. So and also the demand for the drive systems powered by electrical motor will also grow. So thinking about all these aspects. So one thing that we need to keep in mind is that in the future, so these energy consumption and utilization will be higher, and which will create a demand for the energy. But we cannot stop the process. So we have critical process. We cannot stop the plant in order to save the energy. But the way in which we can uh, 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 do is that by using an energy efficient system and in reducing the CO2 emission. So how do we achieve it? By using a high efficient motor and a variable speed drive, so which I'll talk about in the upcoming slides. And talking about industries as a specific, so more than 70% of the electricity is used by the industries. So out of this 70% which is used, so 2/3 of the energy is consumed by the motor alone. So that is the reason this motor plays an important role when we talk about energy saving in industries. So the pressure to reduce energy consumption and lower carbon dioxide emission comes from everywhere. So we will be soon be forced to use a high efficient system in order to reduce the energy consumption. So and the prices are also volatile. Energy prices, if you see, so they can be volatile. That's why we need to take all this into consideration. So now looking at the main causes of the energy waste in a manufacturing process. So there are four main causes. So one is your over-dimensioned motor. And then second one is your low efficiency motor. Third is variable load process running at full speed, and then poorly maintained assets. So these are the four major causes, so which are resulting in energy wastage. So we'll talk about these in detail in the coming slides. The first is your over dimensioning. So I would like to explain this over dimensioning by taking one of the example. So let us take one example, that is your pump. So which is and the requirement is to deliver a flow of 500 meter cube per hour. So for this application, we need a 50 kilowatt motor. So, but keeping the future need into consideration, so we go for a higher flow, which is 600 meter cube per hour. So what our system integrators would do? So they will give additional margin. So maybe a design margin or a safety margin of 10%. So which will increase your motor kilowatt by 10%, resulting in using a 75 kilowatt. And then what your pump selector will do? He'll give additional 10% of margin, so which will increase your further motor power rating by 2.5 kilowatt. So then we'll be selecting a motor which is there in that range, just 90 kilowatt. So now if you compare these two data, so earlier we were required 50 kilowatt motor. So now we are almost doubled than what is required. So we can say almost it is like 100% higher dimensioning of the motor. So this is one of the major concerns where during installation itself it is consuming higher energy. And if as a customer, if you are still following a traditional way wherein you are controlling the motor by the valve, so then it will result in much more losses. So that is why if you are using a variable speed drive or variable frequency drive, you will be able to save almost like 50% of energy. So and then talking about the second ways in which you are wasting energy is your variable load process, which is running at full speed. So if you take an example for any applications where your application is such that where you can operate at different ranges, but you're running the motor at full speed. So there is a lot of wastage of energy because the power which is consumed by the motor in order to run is proportional to cube of speed. So if let us assume that if you're running a motor which is at 50% RPM, so then the energy which is required is 1/8 of the energy which is required to drive at full speed. So you can see the amount of energy that you're saving by reducing the speed of a motor. So how do we achieve it? By using a variable speed drive. So instead of using the conventional way, that is your throttling, or using a bypass means. And what is the third way in which you are wasting energy is using a poorly maintaining your asset. So maybe what are the electric systems that you are available that is currently running in your plant? If you're not maintaining it properly, and that will also result in energy wastage. So what are the main reasons? One is reliance on reactive maintenance, because if your equipment is running for a long time, so eventually that the performance will also get hampered. So you need to take care of these aspects. You need to check what is the current efficiency of the system, and you replace it based on that. And then inefficient practices. So I would like to explain by taking one of the examples. So you let us take a facility where you're running, you'll not be running your production 24/7, but you're still running your HVAC systems all the day. So this comes under inefficient practices. So you can take care of that, like how you can utilize it much more efficiently. And then ineffective scheduling. So and it says like sometimes it's not about changing what you do, but it is about how you do it. So if you have a facility, if you're not planning your or not making your strategies of how you maintain a system properly, then you will be wasting a lot of energy in that as well. Okay, so now so far we discussed what are the four important methods, four important wastage of energies. Then we'll see what are the ways in which we can reduce these wastages. So one is to replace the outdated motors with more reliable and efficient ones. So when I say reliability, why it is required, as you all know, it will reduce your maintenance cost and will increase the product life. So going for higher efficiency motor like IE4 or IE5, so that will give a lot of energy to you. And then second one is installing a drive to control the motor application efficiently. So I think many times we discussed regarding these drives. So having a drive, you already are aware, like I would explain how much energy will be able to save. So this will help a lot of energy in terms of variable speed applications and improving the reliability. So we have a solutions which AV is offering. So we call it as a condition monitoring and condition-based maintenance. So I'll discuss in the upcoming slides. So this will improve the reliability of the overall system. So how it improves, that we will discuss coming slides. So now we'll be talking about what solutions ABB is offering in order to improve the overall system efficiency and the reliability. So first we'll talk about how does ABB improve the efficiency so that the energy consumption gets drastically reduced. So basically this energy, ABB energy appraisal, it is aimed at giving an insight of your motor or the complete powertrain efficiency. So where our experts, AV experts will be able to analyze your complete system and then give the recommendations to you as a customer, whether you want to upgrade the system to the higher efficiency motors, or you want to include a drive, or you want to include any IoT devices to your system, so that the overall reliability and sustainability will be increased. So in this ABB energy appraisal, we have two methods. One is ABB energy application specific, and then one more is digital powertrain energy appraisal. So what this means is that, so basically your application specific energy appraisal, wherein every expert would visit a site or he collects the data from the customer, so manually, and then he'll recommend the customer what he has to do in order to increase the efficiency of the system. And then second one is digital powertrain energy appraisal. So wherein we'll have a IoT device, we call it as ability smart sensor, that will be installed in an electrical system that will be continuously collecting the data based on the data that is available. So we'll be able to make decisions out of it. So we'll talk about in detail about both these methods, and we'll also see some of the success cases that we have. So first of all, we need to identify which one is actually applicable for your applications, whether we have to go for a digital powertrain energy appraisal or an application specific energy appraisal. So that will be first decided. So as I already mentioned you, so in digital powertrain, we have a IoT device which will be installed in the system that will continuously collect the data. Based on the data, we will recommend to the customer on how to increase the overall efficiency. And other one is application specific, where the data is manually collected and then the recommendation will be given. So what our AV experts would do? So from the data which is collected either by manually or from the IoT devices, so they will actually be able to give a report that says what is the projected annual energy consumed by the system, and what is the CO2 saving that you have done, and what is the payback period, because you have invested for this upgrade or this. So it will also tell you by what time you will be able to get back whatever the investment that you've done. And then it comes, and after that comes the implementation. We'll be implementing these solutions, and then we'll be tracking that solution, whether the solution that we have implemented, it is working as per the So, and then I've just taken the snap of the report that will be given as a part of the energy appraisal. So as I already mentioned you, so this will have a asset usage, energy estimation, how much energy you will be saving by upgrading your system to higher efficiency motor or using a drive. And it will also have like what is the maximum load in which your application is running, what is the average load, what is the operating time, and what is the saving potential. So for the current system which is running, what is the potential to save energy if you are upgrading the system? So that will be available in the report, and customer can have a insight on this, and they can upgrade the system accordingly to save the energy. So this is regarding your EVP energy appraisal. And what are the benefits that as a customer would get? One is they'll be able to cut the energy waste and the cost. And second is they'll be able to reduce the CO2 emissions. And third is lower cost on ownership, because whatever the amount that you've invested for these upgrades will be able to recover within a short period. And then minimum disruption to operation, because we'll be able to do this upgrade without disrupting or without hampering the current operation. We'll be able to do it during the shutdown, so that will not hamper the current operation. So we'll see some of the success stories. So I've taken two success stories, one for your application specific energy appraisal and one more for your digital powertrain energy appraisal. The first one is that this was one of the customer. The customer name is Prime Pack Limited. So they are actually the bottle manufacturers from Northern Ireland. So and then what was done is that we have advantage control who is our AVB authorized value provider. So they approached the customer. So customer was still using this hydraulic motors in their plant. So our system analyze the complete system. They got to know like how much energy the customer can save. So they recommended the customer to upgrade the system to the synchronous reluctance motor. So they were using hydraulic motors. Now the recommendation was to change the synchronous reluctance motor with the drive system to control the overall operation. So with this, the customer were able to save almost like 60% of the energy, and now the quality of the bottles that they were prepared was almost increased by 30%. So this was one of the success stories of this application-specific energy appraisal. And second one is your availability digital powertrain energy appraisal. So where we had this Vagati cell pulp mill, which was in Sweden. So they already had a system, all the current system. So what we recommended is to install a smart sensor. So you almost installed almost like 156 smart sensor in the plant. So these sensors were collecting the data and giving the customer on insight of how the overall operation is. So that was giving the overall efficiency of the system, and then that was giving the earlier warnings in case if there is any maintenance or some actions has to be taken. So because of this digital IoT devices, they were able to increase the efficiency furthermore in the plant. So far we talk about how we improve the efficiency so that we'll reduce the energy usage and for the system. So now the question is, how do we improve the reliability of the system? So we have an existing system. So how do we track this performance and how do we improve it? So for that, AVB offers this AVB ability condition monitoring for a drive. So this is our entire powertrain. So where all the components in the powertrain will be monitored by our IoT devices. So for a drive, we have a remote monitoring tool, and then you have a motor where you can see the smart sensors installed, and even for the bearings in the pumps. So you will be able to monitor entire powertrain in one single portal. So that will give you overall performance or the efficiency of a motor of a complete powertrain. And then adding to that condition monitoring, we have something called as condition-based maintenance. So as the name itself says, so you do the maintenance based on the current condition of your system or the current performance of your system. So what normally the conventional way what customers would follow is that they just assume the things and then they do the maintenance. But with this availability condition based maintenance for the drives, so you can actually see I've taken the snap of the portal. So this will talk about, like, it is a simple donut chart with a traffic light symbol. So which is easy for any person can easily understand without having to know the actual drives or motors. So by these traffic light symbols, you'll be able to understand which equipment in your plant is performing well, which is under poor condition, which requires the maintenance. So they can plan the maintenance not by assuming, but based on the actual data or the actual practices available. So by using this condition-based maintenance, so what reliability manager can do, we can actually take a look into this needs and upcoming maintenance. Basically, in this condition-based maintenance, what we are doing is that we'll be predicting the aging of a component. So if you take a drive, so the main components in the drive are the semiconductors and the capacitors and the fan. So those are the important components. So if that fails, so that will hamper your overall operation, and bringing the drive back into operation is also a time-consuming job. So these condition-based maintenance and these algorithms based on the data what these IoT devices are collecting, so we'll be able to analyze and we'll be able to predict what could be the remaining lifetime of each and every product, and when it can fail, or when as a customer you can take a maintenance for these drives. And then these the data which is collected, it will not only tell you in which year it will fail, it will also tell you what is the daily impact on your devices. So if the component, let us take, if it is getting more stress on that particular day, so that particular day you will be able to check, like it will become red or yellow depending on how much is the stress on your component. And this is one of a chart. So as you can see here, so the dark lines, what you're seeing is the current aging of a component. So what our algorithm is doing, so based on this, it is extending the line. So it will be able to predict what is the year in which your component will fail, or what is the year in which you can take a maintenance. And these data are not by the lifetime what manufacturer gives. It is based on the actual data which is collecting, because we are continuously collecting the data from the drives or from the complete powertrain. So these data will be the actual data or actual stress which is there in the component, and we'll be able to predict. And these are the earlier indications to the customer, so that they can plan or they can do the strategies on how to take a maintenance instead of taking it on assumption basis. And we have one of the success stories when it comes to this condition-based maintenance. So this was one of the success story wherein this remote monitoring system or condition-based maintenance system was active in one of the customer. So they were using this ACS 880 drive. So where we had installed this remote monitoring system. So as per that data which is collected by the device, so it shows that within a year this component would fail. So so you are supposed to take a maintenance on that. And even the real-time data that was collected from the devices, so that was telling there was a lot of abnormalities in the temperature. So the IGBT temperature was rising high and low. So that was also predicting that there's some abnormalities or some aging issue with your IGBT. And after that, the IGBT got failed. So this is one of an example from the customer that we have taken. So where our system has actually predicted the actual failure. So this is one of the success stories. So to summarize the overall thing that we discussed, so the worldwide energy consumption is projected to grow by almost 50% by 2050. So as a result of this, the global and local regulations are constantly being tightened to drive companies toward more efficient, energy efficient operations, and to make the plant more energy efficient. So we already have a digital solutions which are already available in the market. So these devices which are there, digitalization or the digital tools which are available. So these will be monitoring the data continuously, and they'll be able to tell as a customer to you, like where to when so that you as a customer you'll be able to take decisions more accurately based on the actual data which is available, and you can identify the areas of improvement in your system. So ABB is the leading the way in digital solutions for energy efficiency for motors, generators, and drives, and we offer digitally enabled services that are accessible to almost any businesses. So in the future, digital outcome-based business models are expected to be normal part of a business life. And at ABB, we have the expertise and the technology to make the transformation to the digital and energy efficient future easier than ever before. So this is regarding the session. Yeah, over to you, Ramesh.
Yes, thank you, Tejas. Really, it is a good presentation, and you opened the eyes of the reliability people. That is particularly maintenance of mechanical maintenance and electrical maintenance, and even the poorly maintained assets. That should be the main. This thing for the old cement plants are there. They should replace with the new technology. This thing. Okay, and the condition-based maintenance, yes, of course, it is very much required nowadays because skill level is very low in nowadays. People are migrating one place to another place, and their only skill levels are very poor. That is why even Government of India also, they have some skill development programs. Okay. So with this condition-based maintenance, one can improve the reliability of the equipments, also the plant. If the reliability is good, then automatically your emission will also be less, because every start-stop you'll have to burn more coal in the system. So really it is very good, and I hope that the participants, they will make use of this condition-based maintenance, and the poorly maintained assets, they will improve in their plants. Thank you, Tejas, once again. Okay.
Yes, sir.
Any question?
now, No, at present, no, sir. Maybe at the end of the session, sir, we'll take, sir.
Okay, right.
So can we invite, sir, next speaker, sir?
Yes, Roshan, you can invite.
Okay. Now we request Mr. Roshan Shoham to start the presentation, sir.
Great. A very good morning to everybody. It's an absolute pleasure being here speaking at the CIA forum. And thank you to Sai Mesa for the quick opening note and Tejas' amazing presentation, right? Before I could quickly get into the presentation, let me quickly share who I am. Suhail Roshan. I am an Industry 4.0 strategist and evangelist working closely with plants in the corporate team for Unified Twin. I'll just share my screen right now and take you into the presentation. And before that, yeah. Great. I think my presentation is visible right now.
Yes.
Yes, sir, it is visible. Just make it full screen. Okay, fine. Yes.
Okay, great. Fantastic. So we at Unified Twin are, working closely upon unifying humans and machine intelligence. What I mean by that is we today are a parent company for Knowledge Lens, which has been 9 years in the industry, focusing upon niche technologies like big data, IoT, and artificial intelligence. It's very well like summarized in the yesterday's session, led by our lead panelists, Mr. Wadwa and Mr. Raju Goel, where they focus that the three major things that today the cement industry requires is to adapt technology, act fast, and move forward. The reason why that has been critical is the government initiatives have been very fast and very vast towards pledging towards the net zero across 2007 2070 has been pledged by the government of India. And today's journey is what I want to create a differentiator with Unified Twin. We are today working closely upon five major offerings that is to do with the yield and sustainability, smart energy, yield optimizer, asset analytics, and remote monitoring. What we are trying to today work upon is seamlessly developing a knowledge base, creating insights towards recommendations and values to that the frontline workers can derive from these applications. The significance value that the application brings today is it's a no-code environment, and it's driven where the AI-driven recommendations give the operator the benefit to like control and move around, creating value towards the entire plant, industrial knowledge base, and edge to cloud connectivity. Before I take you into the journey of every the success criteria that have been worked across on, and the case studies has been vast. Our journey in cement industry has been significantly very good because we have been working closely with some of the leaders in the market, and we have delivered value to them. To begin with, let me take you on a journey where the asset analytics and monitoring has been taken into consideration. It's very well understood that anything that can be which is not measurable, that cannot be controllable. And that is what we exactly did for this customer, where we digitize the whole plant, which can be measurable, and that can be in where every assets can be drilled down and optimized to reduce the amount of carbon footprint that can be released. The significant value the production in the plant team did is they got measurable insights for the production KPIs and the process analytics, to putting together the critical parameters that could be proactive control can be done for the critical parameters. The value that we created is that every morning today the customer works upon opening this application that we put together, runs down to the entire plant, looks up to what is happening at the ground level, the reality of every process, every department, and then creating value towards what is the monthly net production required and how can they maneuver around the entire the need of the industry today. And significant value that is we deliver is here that the downtime required to like proactively enact upon the alert that comes from the KPIs is significantly vast. And here we created that insights that the plant team can work on to reduce the carbon emissions that are happening. The next journey that we today did across was on a predictive modeling. So here, artificial intelligence has been a critical piece in putting together the value towards how we could monitor the emissions that are across the entire plant, which could be creating a huge amount of carbon dioxide emissions across in the environment. So we did a what if analysis on critical parameters, putting together the logics and the transformation on the likeliness of the exceedance level. So here the plant has upfront information that they are going to be critical compliance parameters which could cause issues. What this created is that value chain, every component be it the electrostatic precipitator, the bag filter blockages, or an example for that, a bag filter process being blocked, is what we today like highlighted to the operator that there is high chances that because of your parameters exceeding, and the history that we put together from the data that is being stored on your historian or on from the IoT sensors, we today can tell you that there is a high chance that you can work on rectifying that and be wary of the situation that's going to come for a downtime. This created us 20% better planning to like for the maintenance team required, and that could impact the part of emissions that's needed. So here you, rather than going for a complete shutdown of a particular department, you can have a planned like maintenance days and work tremendously well. The value that this prediction has put across is 100% insights upon how the process operation can be looked into and the likelihood of a problem development. The next journey that I want to take you into is a predictable efficiency. We do understand that over the last year, we saw, a high need of, like coal and a shortage of that being alarmed across the entire media because of, the power demand required for the Indian, industry, especially in the cement sector. With that being said, having an efficient, like power plant is very critical. And that is what we exactly did for this particular customer, where we put together predictive insights upon the how an efficient way the current, power plant could be run. And with the existing, like state of, the system that's there, rather than, like pushing it too hard, but, but efficiently working upon critical, like working on critical parameters with upper and lower limit is what we did. So here, the artificial intelligence-based recommendations have tremendously helped the operator to reduce their raw material being utilized for the same demand that's required in the plant. The reason is simple. As even Tejas mentioned, the rated, values that the OEM supplier speaks about these particular components does not stay the same. And that is the reason why over time the plants deteriorate, with the efficiency they can, render. And when you see that, data that has been, amassed sitting in historians can be utilized to, give, valuable insights to the operator, creating, that, value chain of, upper and lower limit that, critical parameters can be run into. And that is where, we banged on, gave an option there for this customer. This not just created a reduction in the downtime, but also created value in respect to the efficiency that is there. Of course, 0.52% efficiency improvement in the energy generation is very huge. Significantly on the ROI numbers have been on the top of the scale, and that's one of the reasons why the solution has been spanned across to many such locations with this customer. Here we optimize the use of raw material that the plant could use to run the same amount of generation of like fuel for the power generation, and that is where we reduce the amount of carbon footprint that can be released into the world where our next generation is going to come in picture. One good part about this is where the predictable useful life of asset is concerned. We all know that in the cement plant there are critical components which requires major attention because they are the heart and soul of the entire plant. For example, it could be your like precipitators, or it could be your roller mills, or roller press, or a ball mill as well. Just a few examples. The reason why this is very critical is all these components have been installed way back ago, and they require tremendous amount of maintenance. And when there are huge components which require like a timeline of 3 to 6 months of production, and they're not going to be shipped overseas, over water, but overseas, in fact. And that's one of the reasons why having a pre-planned insights on what is the remaining useful life of components that are likely to fail is very critical. And that is where we worked upon this customer to give them insights with artificial intelligence as a soul and heart at the center, giving them insight with respect to, depending upon the current three parameters, three major segment of parameters. One is the rated parameters, the electrical parameters, and then the current real-time parameters. Taking into consideration all these three things, we plotted the entire graph of what are the likeliness and when are the likeliness that this machine requires maintenance, and what is the remaining useful life of your components. We here created a business value of extending the aging factor for these particular assets, reducing the production throughput losses. Certainly, there's a very big problem because the more we lose these things, it deteriorates over time, and then reduction in the maintenance costs. So here we efficiently made use of the particular machine that's already been installed and gave the plant an option that yes, you have a better advantage, let's go ahead. Then predictive modeling, as I was talking to you about, on the work that we've been doing across on the artificial intelligence. This is another example where we work for a customer where we put together a complete digital twin, a model, a simulating model for the electrostatic precipitator. The main concern that they had was, what are the insights? Why is the concern of breakdown and the immediate issues that are causing gaps for monitoring critical voltages and parameters. Here, when we put together all the data that has been residing there, and we understood that, the savings that have been optimized, that could optimize operations, were very vast. And that is what exactly we did. And we significantly, gave a complete, roadmap of, how the electrical energy consumptions have been, worked across. And that created a huge savings for this particular customer. We reduce the harmful emissions that are going across by making sure that the early warnings have been addressed and all the back filters and other components within the electrostatic precipitators have been taken care of. A quick another example of the plant efficiency and sustainability is very clear, because every kilowatt of your energy being generated has a sidekick, that is your losses. Yes, of course. And that is where we gave insights to the plant team that with your generation, be it from the production level till the end of your consumption level, we gave insights on the entire load factor and the aggregating data. This created a value chain with respect to how the energy consumption is happening and the pattern over time, be it on shift basis, on day basis, on yearly basis as well. We give them clear insights and the forecasting required. So through this, be it they are procuring the energy from the state government or the private government grids, be it on IEX trading, we brought together that insight that is really critically required. So this gave a pattern of a shift on different shifts, and certainly that there are times in over months that we notice that there are shift basis in insights that the plants, shift one was taking more energy consumption, and the third shift was not taking much. So this were critical things that we, the plant team and the production team, could look into and address across. So this reduces a significant amount of a 30% reduction in the carbon emission due to better asset efficiencies. So when you know that over your distribution from the generation till your consumption, there are few losses that happens, and you address that at the immediate level, that is where you see that you are saving a huge ton of carbon emission and carbon footprint across the region. Any residual inconsistent qualities of the wastage also was reduced because of huge turnover of raw material being junked out because the quality has not been the same. Covering to the last bit of the slide here, I'm just a quick overview about what we have been doing across all the cement plants, from a KPI monitoring, being data connectivity with the TCS or PLCs or any sensors is what today we've done, both on mobile phone and your web application. Then a digital twin, a twin model for prediction and optimization is what we put today, work closely across with, putting together a process optimization prediction, a model driven optimization for better AI driven insights. Vision has been a focus for the area, with artificial intelligence and computer vision being key area of interest, where safety and plant asset or people have been the center of that. Across the entire region, sustainability and achieving net zero has been a pledge, and we are helping our cement customers all across the globe. That quickly summarizes my session. So yeah.
So, Mr. Roshan,
Yes, sir.
really you are making use of the digitization in cement industries.
Indeed, sir.
It
Indeed,
is a
indeed.
very good presentation, as well as the easily understandable by each and every person. Because in cement industry, normally people they are all very old. You cannot say old people. They have seen much more this thing and changes in the cement industry. Okay, and yes, of course, one has to use this to reduce the net zero at 4.0. So definitely who are all the viewers or who are all the participants, they will definitely make use of this, because I have personal experience on this AI based. Because I cannot mention here, my son is also AI based.
Oh, fantastic, fantastic.
So I know what is AI and what is this thing. So really, whenever anything is required, all people will contact you for digitization in cement industries. Okay, really
Thank you so much.
wonderful presentation.
Thank you so much, sir.
Thank you.
Thank you. So now would like to invite Mr. Hassan Maidin, CTO, Nebesky Labs. Hassan, sir, you may share your presentation and start.
Sure. Thank you, Sagata. Just a second. Yeah. Is it visible, everybody? Hello?
Yes, yes.
Thank you so much.
Visible, sir.
Yeah. Nebesky Labs is on to the mission with enabling digitization and Industry 4.0. And as we know, the core today's discussion was about AI, the artificial intelligence, and today it has been talked much around the world and in India. The basic necessity for doing the artificial intelligence and machine learning models and all these things is based on the collection of data. So this is the part that data abstraction is the key thing, and this is what we do in Nebesky, and who we are, and started in 2016 December, and we have received our first institutional investment in Jan 2020. And right after we launched the product, we were immediately spotted by CII, and we got the most innovative energy saving award. And in July 2021, we have collaborated with the global VFD manufacturer. And September 2021, we have collaborated with the global IT leader. And our team brings 30 years of cumulative experience in IT, OT, and IoT. And customers include Danfoss, Urjanet, Unido. Anyway, so that's all about Nebesky. Now, getting into the problem, if you see, I'm just now getting into the problem. If you see, we digitize factories. Every factory or building has operation technologies. Biggest problem in this, digitization, if you look into this, the unplanned maintenance, unplanned shutdowns, or the with respect to factories, and how to reduce this. Now, one of the key things that with AI, now once the data is up in the platform, then we can use the machine learning models to create performance analysis and performance forecast with respect to processes, and then with respect to products life cycle management, and overall equipment effectiveness, and the entire thing. Now coming to the problem, Why does it matter? Because of course, there's a $50 billion annual cost for unplanned downtime around the world. And when we look into the problem little more in detail, we have figured out that there are segments or the stakeholders, which are nothing but customers, which is nothing but factories and buildings. This includes everything. Now, operation technologies, companies like Danfoss, ABB, and Siemens, and information technology companies, TCS, CTS, Accenture, and automation companies like system integrators. And then there are consultants and domain experts who are trying to do measurements, and verification in itself is becoming a problem for them. The one of the key important thing for the problem for the consultants and domain experts is measurement and verification, because they are doing some analysis based on which they are giving some support and recommendation for, but they are not able to validate and do the performance analysis online. So this is the one of the key thing that we will be enabling. Now, with respect to a lot of IoT hardware startups are available, and there also the when we look deeper into the problem, it is nothing but the software stack. So this is becoming a problem now. When I go up in the cycle, if you see the OT and IT companies, so there are a lot of digitization tools and platforms are wonderfully available. And the challenge becomes with respect to interoperability between the brands and between the protocols and between the networks. So, and automation companies and system integration companies, they're always dependent on the above OT and IT companies, and they're also falling onto the same problem of interoperability, and scalability is becoming problem. So, this is with respect to problem and solution. As you can see, with Enture, for the digital edge layer, which is a physical layer into the factories and buildings, where we will be running our own real-time operating system, and which also has a remote access and programming capabilities. And since it is a server, this has a very easy access and a wonderful way to connect with any type or any brand of energy meters, and similarly with VFDs, PLCs, field sensors. It can, so since we are bringing intelligence in the physical layer, we are able to achieve a wide and flexible range of connections that we could bring in. Apart from this, the physical layer has an advantage of nominalization. Like, this is one of the biggest fundamental idea that we see, where dumb data, in today's world, with the amount of data being collected and the with respect to the amount of data which is actually being consumed and used to do analysis, is very very far apart. Now, to improve that, say let us take a simple example of a voltage, where when the voltage is varying between plus minus 10%, then there is no need to record it, because it's within the nominal range, and 99% of the data becomes dumb data. So these kind of intelligence we are so this is how we are bringing a very economic model to democratize this industry. Now, to go into the detail of the architecture of our software platform, we see, as you can see, the Enture Cloud is a core of the things, and then we are also running a separate physical layer, which is Enture IoT Cloud. And of course, our innovation in the edge computing, which brings down the computational cost drastically, because we will be doing the calculation in the edge layer, and the edge layer, which in turn connects with the OT or operation technology devices like VFDs, PLC sensors. And this entire package has an individual scalable modules of control, monitor, data stream, and edge analytics. And as a package, this can be used by any technology providers or technology product providers, and where we are giving API support, in which over and above the customers can build their data analytics or other things, and this can also be directly communicating with your ERP system like SAP and Oracle, etc. So this is how the thing works. I mean, with that, I would like to complete the presentation and quickly show you for the next 5 minutes for a quick, very small and factory that we have recently done. and we have also secured the permission for showing this. Yeah, you can see here. Okay, so this is one of the small scale factory that we have done where they are manufacturing ARP and FRP cables, and this is basically the exact requirement of the dashboard that the customer wanted to see. They want to see their power factor and kilowatt hour reading, and then current and also the voltage. So and the customer also wanted to see the difference between apparent and power on live, and then they want to see the consumption data. And this the customer, that when they look into the consumption data, as you can see, we can understand that for the past in between 15 days they were having shutdown for the factory for improvement, and they also wanted to see they were having some voltage issues. So they have kept a monitor with the screen where they would want to so like this, whatever the customer want. So the platform support, this is with respect to dashboard. And as a next one, if you see the devices, we can group the devices together, and then every specific workspaces will have specific devices, and then each devices can have number of parameters. So these are the things that actually customer wanted to monitor and see, and then so that is how the exact system will also be working and in the powerhouse. And there is something very interesting in the with respect to this one. We have also calculated the carbon emission that the customer will be doing, and this we this was also a requirement for one of the low carbon technologies that we will be bringing in. So as a next one, if you look into this, so that is with respect to devices. And just to show you a difference between how we can effectively arrange a very quick and versatile platform for the, I will show you another dashboard just for the understanding. So you have seen Nimpa, and you can see another factory where the dashboard is completely different, and here the customer wanted to see with respect to specific devices and other things. If you see in this one, I would like to show some very interesting reports where you can see the specific energy consumption of the cutting machine. The customer was actually having 5 drawing machines and 2 cutting machines. Very again, it's an SME, and the customer wanted to see the cutting machine one energy with respect to what is a production, and and how this is being consumed. And additionally, with respect to the specific energy consumption, since it is a steel rod factory where they are rolling the steel, and then they're drawing the steel, and they are cutting into pieces and selling it in kgs. But since the measurement of the weight was not happening in the process line itself, but then we brought in our intelligence of calculating the rod length, and since we will be having the diameter, so using this and pi r square multiplied by the specific density of the steel, we will be getting the weight of it. And with that, we are able to calculate the production, and production as accurate as 95 plus percentage in the first few months, and that also kept on improving. So if you look into this is with respect to reports, and then there are other things like as I told you, we have calculated the weight of the steel. You can see this there. This is about derived parameters. In the derived parameters, we will have calculated parameters and then combine parameters. So in the calculated parameters, you can it is as simple as adding a formula. I mean, no code low code system. And then in the combined parameters, the customer actually wanted to see the combined energy of all the drawing machines that they were having. So we were able to bring in a software layer of addition, and then we could able to show it to the customer online. and this is with respect to derived parameters, and there is actions and triggers. In the actions and triggers, this is basically necessary for the automation requirements of the customer, based on which, see, in this customer, they wanted to see whenever the voltage is beyond 422. So they want to have they have some very voltage sensitive tripping equipment. So they wanted to keep a voltage alarm where they will be able to see the high voltage, levels. And similarly, you can create any sorts of actions and triggers, and where by using which you can achieve automations as well. And in one of the interesting thing about Ensure platform is, even if there is no internet, the automations that you will be enabling will continuously happen for up to 6 months. The data can also be stored locally, and then once the internet is available, then we can store up to 18 months. That is our standard, but then that can be increased or decreased based on the requirements. And the finally, this is this user access management. So where as I told you, the data security, data privacy is one of the very important cultural change that we are also bringing in in this industry. With respect to data security, we are actually enabling ourselves with SOC 2 type 2 level of certifications, and then ISO 27001 certifications are in the process. Now, by using our user access management, the customer will have the super admin rights to choose the access for whom they can give. For example, if it is a maintenance requirement for a VFD of a specific VFD, the customer can create and enable the VFD manufacturer or the maintenance system to access the data with respect to heat sink temperature of the VFDs, how it behaved for the past 18 months. So this is with respect to user access management. So now the entire thing that I have explained up to now, it is only with the data abstraction and monitoring, analyze, diagnose, and evaluate, and this is the part. Now the final part with respect to AI and all whatever I have said so far, there is there is no artificial intelligence, because the market in itself is in the discovery stage. The knowledge, it is a very initial state. However, with respect to the soft data, once the data is available, then it is very easily possible, once the digitization of any factories with respect to how many number of devices they are having, what is the type of process that is going, how the product, if we can digitize this entire process, then it is possible to create machine learning models with the data to extrapolate and create a digital twin. And that is when we will be having a real artificial intelligence, where we will be doing a new creation of data. So currently, as far as the industry is concerned, even the basic digitization in itself is a very big challenge, and that is the problem that we are solving. So with that, I would like to say, we are providing performance analytics once the data is available. So these are the things. It's completely flexible in the end. So thank you for your time. If you have any queries, I would be very happy to answer them.
Thank you, Hasan. Thank you. Yes, rightly said that the cement industry is the second most energy consumer industry in
Correct.
the world. Okay. So rightly, with the usage of AI and other machine learning, we can really we can reduce the energy consumption. By reducing the energy consumption, automatically the emission levels will also be down, and we can go up to net zero at 4.0. Okay. So
Absolutely.
really, yes, really with the example, the video you have shown is really good. live demonstration. It is like a live demonstration.
It is yeah.
Yeah, it's a live demonstration.
Yeah,
But
thank
only
you, thank you.
one has to give the correct data. A lot of data has to be collected. That is the thing. If the data are correct, then we can evaluate. We can do any this thing. The new technology, digitization. Okay. Really, thank you. People will definitely, cement people will definitely make use of this system. Okay.
Absolutely.
Yes. Whosoever is approaching you, please better give them some solutions. Okay.
Sure. Thank you. Thank
With
you.
the help of CA, with the help of CA is yes, they have got all data bank, all industries, not
Yes.
only cement industry, all other industries. And once again, I congratulate you within short span of time. 2016 startup and 2021 you got the award from CA. It is really
Yes.
congratulations.
Thank you so much, sir. Thank you so much.
Right.
Valuable words.
Yeah, thank you, Hassan sir. Now I'd like to invite Mr. Manish Patil from Aksar Tech Lab.
Thank you, sir. I will be sharing my screen.
Yes, you are now the presenter. You can share your introduce and you can share your presentation.
Is my screen visible?
Yes, sir. Yes, sir. Please go ahead.
Thank you very much for giving me opportunity to present this presentation and few of the case studies from the cement plant. So I myself, Manish Patil, I am from Aksar Tech Private Limited, and I am as a senior manager in from the technical services department. So I'll be presenting on the behalf of Dr. Raguraj Rao. So in this presentation, I included our company brief, what is our approach, and what is our contribution in the particularly in the cement industry in terms of productivity enhancement and energy efficiency improvement. So briefly, what is briefly, I will be discussing about what exactly we are doing. We are in the field of fluctuation assessment and control system optimization. So we have our own in-house developed tool in collaboration with the IIT Madras, that is IoT-based tool, which is basically we are using for the data analytics, and we are collecting some data from any process industries wherever there is a DCS automation. We are collecting the data that is a high resolution data, seconds level interval, 1 second, 3 second, or 5 second, and we are processing this data into our soft that is tool, that is data analytics tool, that is Optimax, and based on the performance, the tool will give different types of diagnosis. Basically, we are collecting the data from each and every controller from the plant. Basically, you are aware of controller at least having three informations, that is it is having a set point given by the operator, process value or measured value from the feed, and output which generates the controller, which is going to the final control element in the field. So these three informations data, seconds level data, we are processing in our tool, and based on the performance with respect to some standards we set in the tool, against the standards, it will give the diagnosis of each and every controller, whether the controller with respect to standard benchmark, it is good, or it is performing absolute, or it is not performing good. Based on the diagnosis, it will give the suggestion, and according to the suggestion, we are taking the actions to optimize the whole control system. So basically, it is a IoT based tool and complementing to world-class manufacturing practices, Industry 4.0 and IoT initiative. So I'll be going through brief. So we heard this term fluctuation or variations many of the times. So every process industry having these type of variations or fluctuations at some level. So who will judge or who will define whether these levels or levels of fluctuations are okay or not okay? So our tool will give the solution based on the its algorithm written inside our tool. So whether the fluctuations are okay or not okay. If these fluctuations are okay with respect to some standards, then no need to take any actions. If these fluctuations are not okay, then it will give the suggestions. Accordingly, we have to take some actions. We will take the actions and we will optimize the control system. So these are the various type of fluctuations you can see here in these images. So we need to find out what is the root cause of for this fluctuation, where the fluctuations are arising from. So we have to, unless and until we have the data, we cannot, by only seeing the trend, live trend, we cannot say the fluctuations are more or fluctuations are less. Unless and until we collect this data, historical data from the DCS, and we process in our tool, then accordingly, the diagnosis given by the tool, we take the appropriate actions. So the fluctuations are coming from the various sources. Those few of the sources are highlighted here. The fluctuation may be coming from the controller itself, which is not tuned very well. And the fluctuations which are coming from cascading automation, which is a master-slave mismatch. The fluctuations may be coming from the fluctuation may be coming from the final control element, which is controlling the control variable, that is maybe wall, damper, or feeder. The fluctuations may be coming from the design limitation itself. During project test, the design itself is wrong. The selection of the equipment, final control elements are wrong. The fluctuation may be coming from the raw material quality or etc. And finally, the fluctuation may be coming from the transmitters or the field equipments, instruments, which are malfunctioning sometimes. So these are the few sources of the fluctuation which disturbs our processes and which which limits our process in terms of increasing the productivity and consumes lots of energy. So what is our target? What is our approach? I will just tell you. Suppose in this case, if I see against the given set point of the controller, whether it is flow, level, pressure, or temperature, the variations are very high. This is the present level of the fluctuations. So operator do not have any margin to increase this set point. So operator will keep as it is running the plant. But what is our approach? What is our target is to reduce these fluctuations, bring these fluctuations 50% or 60%, whatever from the present level. And we will create a margin to increase the set point. So ultimately, our focus is to improve the averages. That will in terms of high productivity, lower utility, less wastage, and also it will increase the operator confidence. Along with this, the process itself gets stabilized. So our normally in routine plant, the management or higher authority will be majoritarily focusing on the interested on the KPI variables. But our approach is from the not only the KPI, we are digging down further to the equipment level. That is, we are collecting the data in the second scale data, that is higher resolution data. We studied the equipment performance, we studied the controller performance. Once these down the line equipments or controllers are okay, then automatically the KPI will be improved very well. So this is our approach. We are targeting to the final control element or control system. Once these operating very well, then automatically our KPI will be improved. This is our approach. So our tool, that is Optimax, we have to give the data, that is already I told, controller data having information of set point, process value, measured value, and controller output. And it will assess the data based on the algorithm written inside. It will diagnose based on the patterns and variations, fluctuations, and it will give the suggestion. Based on the suggestion, we are optimizing the controller system. So it will give, it has a facility of giving 20 plus different statistical measures, that is a minimum, maximum, standard deviation, variance, overshoot, etc. It will give 15 plus types of different root causes diagnosis based on the fluctuations, type of the fluctuations or variations or patterns. And at a time, we can process so many variables, 500 plus variables simultaneously. Within a minute, it will give the performance, or it will give the results. And based on the, it will highlight some diagnosis and suggestive actions it will give. So based on the suggestions, we are taking actions and we are stabilizing the control system. So about Aksar Tech, this is our startup and recognized as an innovative product by CII and approved by the Startup India, mentored by the IIT Madras, and promoted by our parent company, that is Aqualize. So we have associated with a team of multidisciplinary team, that is chemical engineers, instrumentation, and team of mechanical engineers. So these are the sectors we have contributed in cement, metal processing, fertilizer, pulp and paper, glass and ceramic, and power plants. But this tool is not only for this. This tool is designed in such a way that it is it can be used for any of the process industries. Wherever the automation, wherever the data facility is there, data facility for data extraction, we can upload the data into the software, or by hooking up with the DCS, it will take automatically, it will take the data by the defined frequency and it will give the appropriate suggestions. So in India as well as in international, we have contributed. These are our prestigious clients in India as well as in abroad. With this, I will continue with a few of the case studies. What is our contribution in the cement industries with respect to the fluctuation assessment and control system optimization to improve the productivity and to improve the energy efficiency. So this is one of the case study from the one of the cement plants. So where the kiln firing for firing the coal inside the kiln, there is having one pre-bin for the kiln coal feeding. So this pre-bin, the kiln coal, earlier you can see the variations were very high with respect to the coal feeding for burning inside the kiln. And after optimization, what we did here, we adjusted the filling cycle, that is from 5.5 to 3. That is, we adjusted the range of the filling cycle of this bin. And after adjusting the filling cycle, you can see the result here before and after. So ultimately, you can see the average coal consumption. Earlier it was 8.52, and after adjusting the filling cycle range, so it was brought down to 8.41. So nearly we can say net 6 tons of coal saved in one day. And along with this, there is an increase in kiln feed from 282 to 296 TPH, almost 14 TPH has increased. So this is one of the case study from the 12,000 TPD plant from India. So we have done optimization of calciner temperature, that is the heart of the pyro process. So earlier you can see here, before the optimization, the variations, and after the optimization, the variations are different level. So the variations we are seeing in terms of the controller error percentage, and earlier it was 1.5%, and after the optimization, we have brought down to 0.65%. So you can see here the specific heat reduced from 753 to 746. Almost there is a saving of more than 0.5% coal over 3 months. And also there is a increase in AFR consumption also. There is one more case study from our one of the clients from Nigeria. So this is a step-by-step optimization we have achieved. So earlier we targeted the calciner temperature with respect to the coal line as well as gas firing alternately. So we target initially it was the standard deviation in the calciner temperature was 14.7 degree before optimization. We started optimization from here. We started first optimizing the calciner temperature controller, and we brought down the standard deviation from 14.7 to 8.1. After that, we started another critical loop, that is a kiln hood draft as well as undergate pressure. And finally, we after that we brought down the further we brought down the standard deviation from 8.1 to 5.1. And after stabilizing and adjusting the cooler fan flows, finally we achieved the calciner temperature standard deviation 3.1. So finally, I can say from 14.7 standard deviation, we have brought it to 3.1 plus minus degree centigrade. So you can see there is a one up to 1% fuel saving we have achieved after the optimization from the base case. Also, there is a reduction in a specific power and cooler specific air. So this is one of the example from the after the optimization of calciner temperature. We call it in terms of the average controller absolute error. Earlier it was 1%, and we brought it to 0.4%. So this is one of the case studies from the cement plant, that is optimization of the calciner temperature from one of the unit in Rajasthan. So we have done this for the two calciners before and after. You can see here, earlier it was in manual and after it was in auto, and we have optimized this. So benefit of this is resulted in terms of reducing the specific power, and we have made some logics in the cooler, that is AQC inlet temperature with respect to the cooler fans, and we have brought this specific power reduction, as well as we have achieved the megawatt generation, almost 0.9 megawatt we have achieved. So this is also one of the case studies from one of the plant in Thailand. So we started the step-by-step optimization, and we targeted the megawatt generation from WHRS section. So we made some logics in the AQC inlet temperature with respect to the fan flow, and we started the optimization. Earlier it was the megawatt generation, the base case megawatt generation was 14.8. After step-by-step optimization, cooler fan flows adjustment, optimization of the cooler fans, then logic implementation, then finally we achieved from 14.8 to 16 megawatt. So this is another case studies from one of the plant in India. So earlier you can see before optimization, the standard deviation in the calciner temperature was plus minus 9.2 degrees centigrade, and we achieved after the optimization 3.4 degrees centigrade. So accordingly, after step by step, we have optimized all the cooler fans, undergut pressure, whatever the key PIDs are there, we have optimized, and you can see the results in terms of productivity and specific power, as well as green fuel, that is AFR, also increased. So this is a case study from the one of the mill section grinding unit, cement mill, ball mill. So we have implemented one new logic for the bucket elevator ramps controlled by with the mill feed, and you can see the result of the standard deviation of the bucket elevator was brought down from 3.1 kilowatt to 2.4 kilowatt after the optimization. So after the optimizing other controllers in the mill, same mill, we have achieved this increase in the TPD mill feed, and parallelly simultaneously we have brought down the mill specific power. Same mill. Yeah, that's it from my side. Thank you very much.
Yes, really, Manish, with the examples, okay,
Thank you,
one
sir.
can see the change in the mainly in the process parameters.
Yes,
Either
yes, sir.
usage of power or the coal. Okay.
Yes, sir.
And
Actually, we believe whenever there are certain levels of fluctuation or huge fluctuation, we have a confidence that once we reduce this fluctuation at a certain level, even if we reduce 25% from the present level, we can hit the KPI, one of the KPI. That's it.
yes,
Yes.
really being your parent company is Aqua Allies. So
Yes,
you
sir.
should give some value added this product to each and every cement industry.
Yes, sir. Yes, sir. Yes.
Already you may be supplying to all cement industries
Yes, sir.
other castings.
Correct, sir. Correct. Correct.
So this will be useful for the cement industry.
Yes, sir.
Reduce carbon emission.
Yes, sir.
Really this good presentation, and whatever examples you have shown, case studies you have shown is really appreciable.
Sir, because of the time limitation, I have selected few ones. There
Okay.
are so many case studies because of the
So you
time
can-
limitation. I have.
Okay, you can visit each and every cement industry. Then you can tell them, yeah, this is the
Yes, sir. Yes.
real-time analysis what we do and what we achieved.
Correct.
Okay.
Correct. Thank you, sir.
Really good.
Thank you, sir.
Sir, yeah, we have not received any questions so far, sir.
Okay.
But we have requested all the speaker to share their contact details here.
Very
So
good.
we'll share all the details with all the participants, sir.
Okay.
So they can directly contact them if required, sir.
Sure.
So maybe we can wait 1 or 2 minutes, sir. If there is no question, sir, maybe you can conclude the session, sir.
Yes, sir. No issue.
Or if you have, sir, any questions, sir, you can also ask our participant, the speakers, sir, if you have any specific questions.
Oh, I'll ask them because anyway I'll ask them to visit my plant. Okay. Okay.
Yes.
All 4 participants are most welcome to visit our plant. We have 2 cement plants in India. One is at Bharati and another one is at Kalburgi Cement. Okay.
Yes, sure, sir. Sure, sir. Yes.
Yes.
Thank you, sir.
Thank you so much, sir. Certainly look forward for that.
Yes.
Yes. I think nobody is there. I think.
Yeah.
No question.
Yes, sir. Then you can conclude the session, sir.
Yes, really, all the 4 presenters, they have presented very well, and it is very useful for the cement industry. See, one example I'll tell you how the products evaluation connected with smart products. Philips lighting, you can switch off your lights, switch on your lights from mobile. That much digitization it has happened. Sitting at almost from 500 kilometers, 1000 kilometers, you can switch off your lighting with a mobile. Same thing, Medtronic digital glucose meter. One can sit at home and see how much is your sugar level and what level is there. And even now the cricket, maybe everybody watch cricket, T20 cricket. They are measuring the speed of the ball, 156 kilometer speed. Only we know that how much they are measuring the car speed. Now they have started measuring through AI only, all the digitization only.
Correct.
So really it is all digitization is very much required in industries, and some of the skills required for 4.0 industry 4.0 is complex problem solving actually, and critical thinking. So people should think only critically, then only it will we can solve the problems. And creativity. Now in the world nowadays everybody creating one or other things. The AI is in 5 years back no one was heard about the AI or machine learning. Only people were learning some small things with the collecting data and people management. That is very much important actually. Earlier in those days only in the cement industry 1000 people are working, 2000 people are working, 3000 people are working. Other things we can reduce the manpower in the factory and the safety point of view also, and it is better for the industry also. And it should coordinate with others actually. Coordination is main part. So a lot of people, lot of innovations they are having. One industry should know what are the innovations. So CA should have some common platform, like now all the 4 participants they have shown their products. So like that, time to time we should tell the new startups, mainly startups, so they can showcase their what all they are doing. Okay, so we can implement, because startups we should only encourage the startups, unless otherwise the industry people they don't encourage. So where the startup will go?
Yes, yes,
Correct,
sir.
sir. Yes.
That is very much important. And judgment and decision making, that is also very important actually. Judgment. Yes, if he is doing a good thing, then if it is okay, then you'll have to make a small fast decision to implement that industry people they can easily do it. being a very big industries, all industries. If it is viable and it is useful for them, it is some cost saving is there, some emission level control is there. Definitely people should make use of the and service orientation. Already, yes, nowadays service is the main criteria. Whether you sell or not, service is first they'll ask how much service I'll get, what service, what type of service I'll get. That is the main. Startups, normally startups and this type of industries, they give service priority, they will give service priority. So like this, yes, one has to be there, and digitization is very much important. We'll have to do. And in cement industry, mining activity, you take mining activity or maintenance activity, operation, like what Mr. Aksar was telling, and even quality control.
Yes, sir.
And packing and logistics. These are all the main in cement industry. Cement industry can adopt these type of technologies. Okay, this 4 we have seen, but many other people may be using some other technologies, AI-based technologies, machine learning technologies, IoT, everything. So definitely this will be useful for the industry as well as for the country and for the globe. Okay,
Correct.
thank you all. Okay,
Thank you very
please
much.
So much,
share
sir.
your presentations. Please
Yes,
share
sir.
your presentation to Mr. Saugat, then he
Sure.
will.
Sure, sir. We'll
Sure.
share all the presentation, sir.
Right.
Thank you, sir, for your wonderful remarks and valuable time and joining this session, sir.
Yes, thank
And
you.
we also thank all the speakers joining this
Yes.
session. Thank you so much. And please share your contact details and the PPT with us, and we'll share to all the participants as well as chairman, sir.
Yes.
Sure, sir.
Convey
Thank you
my
so much.
regards to
Thank you very
chairman and co-chairman. Okay.
Yes,
Saugat.
Sure.
Sure.
Sure, sir.
Thank you so much.
Thank you.
Thank you so much, sir.